Hello grade 11 students. In this video, I'm going to discuss the lesson about solving rational equations and inequalities. Objective: solves rational equations and inequalities. Let's have a review on factoring polynomials. So the first one is the difference of two squares. So for the difference of two squares, let's say a squared minus b squared. The factors will be a plus b times a minus b. So for example, let's say we have x squared minus 9. And we know 9 can be expressed as 3 squared. So the factors of x squared minus 9 is x plus 3 times x minus 3. Another one, let's say, what are the factors of x squared minus 49? So 49 can be expressed as 7 squared. Therefore, the factors are x plus 7 times x minus 7. Next one, let's factor x squared plus 5x minus 14. So, first is, the first term here are the factors of the first term in this trinomial. So the factors of x squared is x times x. Then we'll think of the factors of negative 14, that wherein the sum of the extremes and the means must be equal to positive 5x. So the last term here is negative. It means that the two factors have different sign. One is positive and the other one is negative, because positive times negative is equal to negative. So again, if your last term is negative, it means the two factors have different sign. One is positive and the other one is negative. So what are the factors of 14? The factors of 14 are 14 and 1. 14 times 1 is 14. And 7 and 2, because 7 times 2 is also 14. So these are the factors of 14. But which pair will lead us to 5? That is 7 times 2. 7 times 2 is 14, and 7 minus 2 is equal to 5. Now the middle term is positive, so the bigger digit will have that sign. So therefore, 7 will be the positive one. So we're going to place it here. And then 2 should be the negative one. So we're going to place 2 here. So let's check. X times x is equal to x squared, and positive 7 times negative 2 is equal to negative 14. And then when we multiply the extremes, negative 2 times x is negative 2x. And when we multiply the means, positive 7 times x is positive 7x. And then combining these two, negative 2x plus positive 7x is equal to positive 5x, which is the middle term in the trinomial. Therefore, the factors are x plus 7 and x minus 2. Let's have another example. X squared minus 9x plus 18. So, the factors of x squared is x times x. Next, the third term here is positive. What does it mean? If the third term is positive, it means the factors that we should write should have the same sign. Either they are both positive or they are both negative. because positive times positive is positive. Also, negative times negative is also positive. So again, if the third term is positive, it means the factors should have the same sign. Now, is it two positives or two negatives? Looking on the second term here, it is negative. So, when we are going to write two positives, it's impossible to obtain a negative middle term. So, meaning, it should be both negative. So, what are the factors of 18? We have 18 times 1, 9 times 2, and 6 times 3. There. So, these are the factors of 18. But which pair will lead us to 9? It is 6 times 3. 6 times 3 is 18, and 6 plus 3 is equal to 9. So, we're going to use these numbers. Alright, so it doesn't matter where you're going to place 6 or 3 since they are both negative. Oh, so this must be 3. So let's check if this is correct. So x times x is x squared. Negative 6 times negative 3 is equal to positive 18. And then multiplying the extremes, negative 3 times x is negative 3x. And then multiplying the means, negative 6 times x is negative 6x. And then finally adding these numbers, negative 3x plus negative 6x will give us negative 9x, which is the given middle term. So, means our factors are correct. Factors are x minus 6 and x minus 3. Next, how about this one? X squared minus 4x. So notice that on both terms, there are x involved. So it means we can factor out that common factor. So factoring out x on both terms. So x squared divided by x is equal to x minus 4x divided by x is equal to 4. There. So this expression is equivalent to this one. Although this one is just factored already. Okay? But when you do distribute x, bring it back. So x times x, that is x squared, and x times negative 4 is negative 4x. So we are just factoring these expressions. Okay? Next, this one, 5x plus 10. What is the common factor in these two terms? Okay, so both terms can, as a common factor, which is 5. So we can factor out that 5. So 5x divided by 5 will leave as the x. And then 10 divided by 5 is 2. There. Example number 1. Simplify the given rational expression x minus 3 over x squared minus 9. So let's simplify this rational expression. How? By factoring the expressions that we can factor. So which can we factor? Is it the numerator or the denominator? Yes, it is the denominator. So this is an example of difference of two squares. So we will just copy the numerator x minus 3 and let's factor the denominator x squared minus 9. So the factors of x squared minus 9 is x plus 3 and x minus 3. Now after factoring the denominator, we can now see that there is a common factor in the numerator and the denominator, which is x minus 3. So from there, we can cancel it. And what will be left is 1 over x plus 3. X plus 3. There. So this is the answer. Example number 2, multiply the given rational expressions 5x minus 1 over x squared minus 4 times x plus 2 over 5x squared minus x. So, which expressions can we factor? Both the denominators on the right and on the left side. So, we can factor x squared minus 4 and we can also factor 5x squared minus x. So we will just copy the numerator 5x minus 1 and then factoring x squared minus 4 will give us x plus 2 and x minus 2 times, copy the other numerator which is x plus 2 over factoring 5x squared minus x. So by looking at on this binomial, you can see that there are both x's on these terms. So that is the common factor. We can factor out x. So 5x squared divided by x is equal to 5x. And then negative x divided by x is equal to negative 1. There. So after factoring, we can now see that there are terms that we can cancel. Which are those? X plus 2 and 5x minus 1. So we are now left with 1 over x minus 2 and x. So x minus 2 times x. So finally, we will just distribute x to these terms. These two terms. Like that. So we'll have 1 over x times x is x squared. And x times negative 2 is negative 2x. So this will be our final answer. Example number 3, find the sum of given rational expressions with like denominators. 2x plus 11 over x plus 2 plus 2x minus 3 over x plus 2. So in this case, that when we are adding or subtracting rational expressions with the same denominator, so we will just simply add or subtract the numerators and then copy the common denominator. So, we'll have 2x plus 11 plus 2x minus 3 over the common denominator, which is x plus 2. And then combine like terms. So we can combine the 2x here and the other 2x. So 2x plus 2x is 4x. And then we can also combine positive 11 to negative 3. So 11 plus negative 3 is equal to positive 8. Then write the denominator x plus 2. Now we're not yet done because the numerator for x plus 8 can still be factored. So let's factor it. What is the common factor between these two terms? It is 4. We can factor out 4. So factoring out 4, 4x divided by 4 is equal to x plus 8 divided by 4 is equal to 2. There. And then again, copy the denominator x plus 2. And you can now see that we can cancel x plus 2. Therefore, the answer here is positive 4. Next, example number 4. Find the difference of the given rational expressions with unlike denominators. 7 over x plus 4 minus 3 over x minus 3. So in the case that you are adding or subtracting rational expressions with different denominators or unlike denominators, we have to use its LCD. We should have an LCD or least common denominator. So in this example, the least common denominator would be the product of these two binomials, x plus 4 and x minus 3. There, so that will be our LCD. So, we are going to use the LCD x plus 4 and then x minus 3. And then LCD divided by the denominator. Again, LCD divided by the first denominator. So let me show it. This is the LCD divided by the first denominator, which is x plus 4. So LCD divided by x plus 4 will give us x minus 3. And then that answer, we're going to multiply it to the first numerator, 7. So 7 times x minus 3. And then copy the operation, which is minus or subtraction. Then, for the second rational expression, same process. LCD divided by the second denominator. So again, LCD, this is the LCD divided by the second denominator, x minus 3. So cancel, we will have x plus 4, and then we are going to multiply it to the second numerator, which is 3. So 3 times x plus 4. There. So what's next? Next is to distribute these numbers. So 7 times x and 7 times negative 3, and then negative 3 times x and negative 3 times 4. So let's answer that. 7 times x is equal to 7x, and 7 times negative 3 is equal to negative 21. And then negative 3 times x is equal to negative 3x. And then negative 3 times 4 is equal to negative 12. And then just copy the LCD, x plus 4, x minus 3. So the next step here is to combine like terms. So the like terms here are 7x and negative 3x. So 7x plus negative 3x is equal to 4x. And then combining negative 21 to negative 12 will give us negative 33. And then copy the denominators, x plus 4 and x minus 3. That's it. So this will be the answer. Solving rational equations. Rational equation is an equation containing at least one rational expression with a polynomial in the numerator and denominator. It can be used to solve a variety of problems that involve rates, times, and work. The first thing to be on your mind is in solving rational equation is to eliminate all the fractions. So let's have an example. Example number 5, solve the equation 2x minus 3 over x plus 1 is equal to x plus 6 over x minus 2. So, solving the equation means finding the value of x that will make this statement true. Okay, so to answer this, what we're going to do again is to eliminate the fraction, and we'll do that by doing the cross multiplication. So we are going to multiply this denominator x minus 2 to the numerator 2x minus 3, and then this denominator x plus 1 should be multiplied to the numerator x plus 6. Okay, so let's write it. X minus 2 is 1 times the numerator 2x minus 3. And then copy the equal sign. Then on the right side, we will have x plus 1 times the numerator x plus 6. There. So, from this line, you can see that there is no rational expression involved anymore. No more fractions. So, we are going to multiply these binomials. So, by FOIL method, first is to multiply the first term. So, x times 2x is equal to 2x squared. Then, let's multiply the extremes, which is negative 3 times x, and that is negative 3x. And then multiply the means. Negative 2 times 2x is equal to negative 4x. And lastly, multiply the last terms, which is negative 2 times negative 3. And that is equal to positive 6. Now on the right side, x times x is equal to x squared. 6 times x is equal to 6x, or positive 6x. And then positive 1 times x is equal to positive 1x, or positive x. And lastly, 1 times 6 is equal to positive 6. And then combine like terms. So in this side, on the left side, we can combine negative 3x and negative 4x. So simply copy 2x squared. Then combining negative 3x and negative 4x will give us negative 7x. And then copy positive 6. On the right side, we can combine these two terms. So copy x squared. Then 6x plus x is equal to 7x. And then copy positive 6. There. So the next step here is we can actually transpose or move these terms on the right side to the left side, so that we'll be able to combine like terms. So again, these three terms here should be moved on the left side, or transposed to the left side. But when you move it to the left side, of course, the sign should change. Each sign should change. So we will copy this one. 2x squared minus 7x plus 6. Then, transpose positive x squared, it will become negative x squared. And then, positive 7x will become negative 7x. And then positive 6 will become negative 6. And there will be nothing left on the right side, so we're going to write 0. Now from here, we can now combine like terms like these two 7x and the two terms with x squared. And we can also combine the two constant terms here. So let's combine. 2x squared plus negative x squared is equal to positive 1x squared. And then negative 7x plus another negative 7x is equal to negative 14x. And then combining positive 6 to negative 6 is equal to 0. So I don't need to write it here anymore. Again, 6 plus negative 6 is 0. And then equals 0. There. And then, what have you noticed on these terms? We can factor out x. So factoring out x on both terms. So x squared divided by x is x. And negative 14x divided by x is negative 14. There. So there are two factors here, x and x minus 14. We're going to equate both factors to 0. So the first factor is x, equate it to 0. So x is equal to 0. That's 1. And then the other factor is x minus 14. Equate it to 0 and then solve for x. So we're going to transpose negative 14. It will become positive 14. So we now have two answers. The two answers are 0 and 14. Okay? But let's check if these are both solution to the given rational equation, because there are times that we can have an extraneous root, or a root that is not part of the solution in the given equation. So again, our answers are 0 and 14. Let's check if they are both solution to the equation. Alright, so our answers are 0 and 14. So checking, how do we do the checking? We will simply substitute or replace all x's by these values to check if they are part of the solution, or if they are the solution to the given rational equation. So let's start by 0. If x is 0, So we're going to replace all x's with 0. So 2 times 0 minus 3 over 0 plus 1 equals 0 plus 6 over 0 minus 2. So 2 times 0 is 0 minus 3, that is negative 3, over 0 plus 1 is 1. On the right side, 0 plus 6 is 6, and 0 minus 2 is negative 2. There. Next, let's simplify these fractions. Negative 3 over 1, in lowest term is negative 3. While 6 divided by negative 2 is also negative 3. Therefore, it is true. Okay? It is true that negative 3 is equal to negative 3. So it means the value of x, which is 0 that we used, is a solution to this rational equation. Right? So this time, let's try 14. If x is 14, let's see if the statement or the equality of this rational equation, of this rational expression, is still true when x is 14. So let's replace all x's by 14. So 2 times 14 minus 3 over 14 plus 1 equals 14 plus 6 over 14 minus 2. There. So 2 times 14 is 28 minus 3 is 25. And then on the denominator, 14 plus 1 is 15. On the right side, 14 plus 6 is 20 over 14 minus 2 is 12. There. So the lowest term of the fraction 25 over 15 is 5/3. While the lowest term of the fraction 20 over 12 is also 5/3. Therefore, it is still true. Therefore, if x is 14, the statement or the rational equation is still true. So it's also a solution. So both numbers here, 0 and 14, are solution to this rational equation. Next one. Solve the equation x plus 2 over x plus 3 equals x minus 7 over x minus 3. So again, cross multiply x minus 3 times x plus 2. And then on the right side, x plus 3 times x minus 7. Then let's multiply these binomials. X times x is x squared. Then 2 times x is 2x. Then negative 3 times x is negative 3x. And then negative 3 times 2 is negative 6. Now on the right side, x times x is x squared. Then negative 7 times x is negative 7x. And then positive 3 times x is positive 3x. And then lastly, 3 times negative 7 is negative 21. There. Then, let's combine these terms. So, we'll have x squared, copy x squared, and then 2x plus negative 3x. Positive 2x plus negative 3x is equal to negative 1x. Then, copy minus 6 equals, here, copy x squared, and then combine negative 7x and positive 3x. That will give us negative 4x, and then copy the last term, negative 21. There. So the next thing to do is to transpose these terms on the right side to the left side. So x squared minus x minus 6, and then positive x squared will become negative x squared. Negative 4x will become positive 4x, and negative 21 will become positive 21, and then Nothing left on the right side, so we will write 0. Then we will combine like terms. So x squared plus negative x squared is 0. So it will be cancelled. Next, negative x plus positive 4x will give us 3x. And then negative 6 plus positive 21 will give us positive 15. There. Then to solve for x, we transpose 15 to the right side, so we'll have 3x equals negative 15. So positive will become negative. And then lastly, divide both sides by 3. So the final answer would be negative 15 divided by 3, that is negative 5. So that's our answer. X is negative 5. Next, solving rational inequalities. Rational inequality is an inequality which contains one or more rational expressions. Solving an inequality is much like solving a rational equation, except that there are additional steps that focus on illustrating the solution set of an inequality on a number. So let's have an example. Solve the inequality 2x minus 8 over x minus 2 greater than or equal to 0. So the first step is to write the rational expression in the form r of x over q of x greater than 0, wherein the greater than here can be replaced by less than or greater than or equal to and less than or equal to. Now, so the given here is already in this form. And then the next step is to write it in a single rational expression on the left side. So on this given, it's already a single rational expression on the left side. So we will proceed with the third step, which is to equate the numerator and the denominator to 0 and solve for x. So for the numerator, 2x minus 8, equate it to 0 and solve for x. So the value of x, 2x is equal to, transpose negative 8 will get positive 8, then dividing both sides by 2, and that will give us a value of x which is 4. 8 divided by 2 is equal to 4. Alright, so that's 1. That's the value of x in the numerator. Now for the denominator, which is x minus 2, equated to 0, the value of x will become positive 2. Now what are these? These numbers are what we call the critical value. So in this example, in this rational inequality, we have two critical values, positive 4 and negative 2. So the critical values are 4 and 2. So we're going to draw it in a number line. So if 0 is located here, then we will have 2 over here, and then 3, and then 4 over here. Now, we need to know if these critical values are included in the solution. So to know if they are included or not, we are going to substitute these values to the given rational inequality, and let's see if that will make the statement true. So let's try 4. If x is 4, so replace all x's by 4. So 2 times 4 minus 8 over 4 minus 2. So 2 times 4 is equal to 8 minus 8, and that will be 0. Then 4 minus 2 is equal to 2. And we know that 0 over 2 is equal to 0. So 0 is greater than or equal to 0. So it's true. If x is 4, we will have 0, which is greater than or equal to 0. So meaning that critical value 4 is included in the solution. So we're going to draw a shaded circle over here on the number line on number 4. Now let's try 2. Let's see if 2 is also included in the solution. So we're going to replace the x by 2. So let's replace x by 2. There. So we have 2 times 2, which is 4, minus 8 is negative 4, over, on the denominator, 2 minus 2 is 0. So negative 4 over 0 is undefined. So since it's undefined, it means that critical value 2 is not included in the solution. So on the number line, we're going to draw on that critical value a hollowed circle like this. There. So if the critical value is included in the solution, you have to draw a shaded circle. But if that critical value is not included, then you have to draw a hollowed circle. 2 is not included because when you replace x's by 2, it doesn't make the statement true because it's undefined. Alright. Now the next step is to know where the solutions lie in the number line. Is it over here? Are the solutions lie in this area from positive 4 up to the positive infinity? Or is it in between 2 and 4? Or is it from positive 2 to the negative infinity? So to know that, we're going to test some numbers. So we're going to test some points. So we can use the number here on the left side of 2, which is 1. So we're going to test that point. If that point will make the statement true. If that point, if x is 1, if that point will make the statement true, then it means the solutions are lied on this part. It lies on this part. Next, another testing point would be the number here between 2 and 4, which is 3. So if x is 3 and it makes the statement here true, then it means the solution lies within this area. And then another testing point will be the number on the right side of 4, which is 5. So if x is 5 and it makes the statement true, then it means the solution lies over here on this area. So let's start. Let's try 1. So we will just substitute or replace x by 1. So we'll have 2 times 1 minus 8 over 1 minus 2. Is it greater than or equal to 0? Let's see. 2 times 1 is 2, minus 8 is negative 6, over 1 minus 2 is negative 1. There. And negative 6 divided by negative 1 is positive 6. Okay? Now, is positive 6 greater than or equal to 0? Yes. 6 is greater than 0. Right? So it means, if x is 1, it makes the statement true. So what does it mean? It means that the solution lies over here on the left side of the critical value 2. Remember, we have two critical values, 2 and 4. So the testing point 1 makes the statement true, so the solution lies over here on the left side of the critical value 2. Alright, now let's try 3. So we're going to replace x by 3. So 2 times 3 is 6, minus 8 is negative 2, and then 3 minus 2 is 1. Negative 2 divided by 1 is negative 2. Now, is negative 2 greater than or equal to 0? No. It's not true that negative 2 is greater than or equal to 0. Therefore, it means that on this area, since we use that testing point 3, on this area, there is no solution here. Right? There is no solution in between these two critical values 2 and 4. Next, how about 5? On the right side of the critical value 4. So this time, let's replace x by 5. So, 2 times 5 is 10 minus 8, that is 2. Over 5 minus 2 is equal to it's 3. 5 minus 2 is 3. Alright. Is 2/3 greater than or equal to 0? Yes. It is greater than 0. So, on this testing point, it shows that the solution lies over here. There is also a solution on the right side of the critical value 4. So, since we know that the solution lies over here on the right side of 4, so we are going to draw lines here, showing that the solution are over here on this area, starting from 4 up to the positive infinity. So, that is endless. Next, and then there's also a solution on the left side of critical value 2. So, we are going to draw a thick line over here, showing that the solution lies on this area. There. So, finally, we are going to write the answer. So, the solutions are from the negative infinity up to 2. But remember, 2 is not included. That is why the circle here is hollow. And another solution can be found on this area from positive 4 up to the positive infinity. Alright, and 4 is included. So, if a critical value is included, then you're going to use a bracket. But if a critical value is not included, then you have to use a parenthesis. So, our final answer would look like this. It starts on the negative infinity, and it's endless. It's endless. There is no endpoint for that. So, we're going to use parentheses. So, from negative infinity up to what? Up to the critical value 2. So, comma, 2. This means from negative infinity up to 2. But, since 2 is not included, it's not included in the solution, then we are going to use a parenthesis, not a bracket. So, that's one solution. Another solution is on this part. So, we have to write union or addition or plus. Solutions are this area plus another area over here, which starts from 4 up to the positive infinity. Now 4 is included, so instead of parentheses, we're going to use a bracket because it is included. And we know that infinity is endless, so parentheses for that. That is the final solution for this rational inequality. Alright, so that's it for this week's lesson. Thank you and God bless.